get straight to the point, right? I was supposed to talk about transportation, but I haven't done that in a long time. I'll talk about collecting lots of contextual data from people's phones. Also a very interesting topic to a lot of us, right? What are the challenges? Let me give some of the background. I'm actually running a thing called Livelabs. Now, what is the problem Livelabs tries to solve? I'll do the academic thing. You have a young assistant professor. He's saying amazing mobile sensing app. MMSys deadline, I'm from the MMSys community. Less than 3 weeks. How do you test with real users? Just extrapolate this to, SIGGRAPH, ACM multimedia, etc. You have some amazing mobile app. You want to test it with real users. So you go, yeah, let's just test it with lab users. Claim it's real world. Nobody knows the difference. And then you get your reviews back and you go, wow, they did know better. Okay, how do I actually test it with real values? And that's where we come in. Right? So what my group is actually doing, I'm one of the directors, that's another director, is we are actually instrumenting 4 real-world values. One is SMU. We actually have, this is going to be fun, this thing keeps flicking up. Okay, so we actually have 4 real-world values. SMU is one, and we have, if it doesn't work, that's fine, I can hack it. It's on up here, it doesn't want to project. Yeah, so, okay. So let me go fast. So what Livelabs is supposed to do is we are trying to, this video will basically explain, we want to do in situ mobile experimentation, right? Which means that if you have any kind of mobile, nothing is working. Okay, say, okay, fine. He's right, it's displaying perfectly fine on the TV behind. Oh, okay, it's just pretending. So we shall not believe it, okay? So what Livelabs is supposed to do is we're supposed to be able to instrument values so that if you have any kind of mobile strategy, right? Mobile promotion. Say you want to test whether giving people promotions where they go left versus going right is good if you want to attract them to go into a store. To do this, you need you need participants in a mall, and you need access to data from them. We are the ones that provide the middleman service for you. So at SMU, we have 2,000 students signed up. We have about 800 people who run our app. Right, I can show you the app later. And we collect data from their phones, iOS, Android, everything. And then we analyze this to figure out what is their current context. Are they in groups? Are they hungry? Are they moving here? Are they there? So we do a lot of work in context sensing. Right? And with that, we provide a platform where you can come and specify an experiment. An experiment could be something like target students who have just left class who are hungry. At that point in time, send them my cool app that shows them where to go find food. And let me see whether that gets to take out the app higher than normal if I just send to everybody. Right? So we allow you to test outcomes like this because we'll actually monitor the students after we send them the incentive and see what they do. Right? Whether they go left, whether they look at the app, whether they deleted it, whether they didn't care. And we'll send all those results back to you so you can figure out what performance outcomes you had. Right? If you just did it SMU, it's okay because you get only students, right? But we're also going live at Changi Airport, which you all came through. And we're also going in one of the malls nearby, Plaza Singapura. And possibly Sentosa. So we're also going to get members of the public in real environments. Now, related to that, one of our key technical challenges is how do you do context sensing? Because to do that, you need to collect data from people's phones. And fundamentally, the big problem with that is energy. Right? Few of you will say privacy. Turns out for undergrads, they could care less about privacy. Shocked the heck out of us, by the way. Because we put in all these privacy policies and nobody cared. The only thing they cared about is why is my phone getting hot? Right? So first and foremost, energy. And it turns out that this is the fundamental problem with context collection from smartphones. You either get accuracy or you get privacy, or you get energy. You can't get both. So you have to be clever. And I actually had a lot of graphs showing the problem. Right? So all of you have worked with accelerometer, smarts, or inertial sensors, gyroscope, compass, or some variant of this before. And you've all seen the graph showing that power goes this way. There is a hidden message that nobody tells you. It looks like the power is actually very low. But it's very low under one very specific assumption. Does anyone know what that assumption is?
Display sound?
No, you're not doing anything with the data. It's very low if you read the data and then dump it to def null. If you actually use the CPU or write it to flash, your power goes up at least 5 times if you're collecting 100 Hz. Because it turns out the CPU and the flash are incredibly power hungry compared to the accelerometer. So that is the hidden message most people don't tell you when they show you these nice graphs, right? If you actually try to use it, your power budget is out the window, right? But why are you collecting if you're not planning to use it? And you can pick one of many poisons. You use the CPU, you use the flash, or you use the network. All of them will eat into your power budget. So you have to do a lot of duty cycling, you have to do a lot of smart filtering and stuff like that. And you could do it if you were the only application. The problem is, in a context like Livelabs or something that would be real, you have more than one application. So if you had an application that wanted accelerometer at 100 Hz and one that wanted at 20 Hz, you're going to have to run it 100 Hz, which means your energy budget is out the window. And every phone is different. This is the other problem. Heterogeneity is what kills us in the real world. You know, this is what I had slides on, saying that heterogeneity is a real problem with collecting contextual data like this. We have a lot of experience. A Samsung S4 power numbers are completely different from HTC One, right? And what I mean by different is the accelerometer plus, say, some other sensor numbers will be completely different if you go to HTC One. Sometimes you get linear scale up, sometimes you get sublinear, sometimes you get superlinear, right? Or you get exponential scale up when you add different sensors because of the way the chips are done. And you have to factor that in for every device. Otherwise, you're going to get a very strange user experience. You try to go live, right? The 5S iPhone is so different from 5C, right? Some of you might know this, but most of you probably don't, that they have different chips. And they have very different power budgets, right? And if you have 3 different applications all fighting, well, now you have an optimization problem, which is very strange. So that's what I wanted to talk to you about, right? The problem of my report is actually very negative because we actually try to deploy this for real. And we are finding that, all the past, it's one thing to do for one application. You get it really well for one application, Jigsaw, whatever is in the literature, they can do it really well for one app. You try to do 3 apps together across 4 different types of phones, everything you read in literature goes out the window. Right? You end up draining either all the power or you drain nothing because you can't collect anything. So that is the challenge I wanted to pose, right? Which is, in this world of, when you want to collect multimedia data, the problem is if you're going to do it from the smartphone, you have to handle heterogeneity. Right? Heterogeneity is a very big problem if you want to do it from the phone, right? Because it eats into your energy budget. And that's exactly what I wanted to show, tragically. Thank you.